So yeah, this is a Python workshop on JavaScript because, well, officially because François is out of Python presenters. No, I wanted to do a presentation on JavaScript because it's a language I tend to use a lot. And hopefully it'll be useful for a lot of you as well. And why JavaScript? Well, there are many reasons we in research could use JavaScript, and that make it an important language in our arsenal. First and foremost is that often when we want to present things, results, we need some form of presentation, so graphic user interface. And the easiest for that is to go with HTML. And once you've done that, you're stuck with JavaScript because that's the way the web works. I've added, because this is a Python workshop, the idea that often we do that with Python notebooks if those are enough, but sometimes they just don't suffice. And even if you're going to present results in a Python notebook, if what you have in the notebooks isn't enough, sometimes you just have to add JavaScript to show the right stuff. So it's definitely something that you'll get to use quite often in that context. You can also use it when you're building distributed applications. It's very convenient because due to its background as a browser language, it has a lot of built-in asynchronous support. So we had a few weeks back the async IO presentation for Python. Those sort of features are built into the core language in JavaScript, which makes it really convenient when you have distributed asynchronous operations. There's also because you have to sometimes. There's a bunch of libraries in JavaScript where you want to use them while you're stuck with JavaScript. So that's a real reason to use it now and again, and for fun, or because you want to pimp your personal web page. Same thing happens that you have to use JavaScript. So a bunch of good reasons and not so good reasons to use JavaScript. And the focus of this presentation, at first I was going to go with like the quirks of the language, but thinking about it and past experience, I realized that one of the hard things when diving into JavaScript for the first time is sort of knowing where you are and what you want to do with it. JavaScript is a weird language, not so much by its syntax, there are quirks, but also by the whole, I don't like to use ecosystem around it, but the way it's used is quite unique in some aspects. So I'm going to talk about the different flavors, if you will, of JavaScript. And to do that, I'll bring it back to Python. So, bold claim. I tend to think that the biggest revolution in the history of Python, in the way we use Python, is notebooks. Basically, when notebooks were introduced, it fundamentally changed the way we do Python and how we think our Python code. Before that, you would just do scripts. Now we can either do scripts or notebooks, and both have their usage. And when you go into a Python project, you choose one or the other depending on your needs. And this is pretty unique to Python. Most other languages, well, you're going to write C. There's really only one way to write C, even if depending on what you're doing in the libraries, you'll have small changes here and there. It's going to be writing code in a very standard manner, and that's true of most languages. JavaScript, on the other hand, has undergone quite a number of similar revolutions, shall we say, and there are really fundamentally different ways of doing JavaScript. And this is kind of what I want to get across with this talk and sort of present those ways. And to do that, we need to understand its history and how the language has evolved with the web, with designing for the web, with the usage of the web. And so in a way, this presentation will take a almost historical approach, just to show how the language has been conceived over the years and how that has altered a way of using it. For clarity, when I talk about web, I'm really thinking web pages here, not internet and REST APIs or things like that, really. the concept of in-browser web. So to begin, one of the things that really makes JavaScript different by being a browser language at its core is that the equivalent of system calls are going to be very different. And I'm going to illustrate that quickly with a hello world example. Most languages, if not all, hello world is going to, the hello world example is going to be a system call to write something to std out to the console. And you can do that in JavaScript if you're doing JavaScript in the terminal, which is the case when you use Node.js, which is a JavaScript interpreter for terminal. And then your hello world is going to be your typical hello world where you just print it. So console log is the equivalent of print. There you have it. But when you're in the browser, hello world becomes complicated because you have multiple ways of doing it, and all of them are legitimate and don't achieve the same goal. The easiest one is obviously to do the same thing, print hello world to the console, to the browser console, but then you're actually not showing it to the user. So I'd argue this is a bad hello world for JavaScript because it's not showing hello world in a browser. So if you want to show it to the user, you actually have two options. One of them is the alert, which is actually telling the browser show this to the user, and the browser will do it through a pop-up dialog, through a dialog. The other approach is to actually put hello world inside your HTML. So here you need to actually grab the HTML and inject hello world in there. And this is probably the most hello world you'll get in JavaScript. This is really what you would expect from JavaScript, is printing hello world in the web page. We're here to do web pages. And what's interesting here is these three examples all do different system calls. And we get the sense that our environment, what we can interact with in JavaScript, especially in a web page, is very different from other languages. I don't have access in the web page to a file system or things like that. And those are going to shape, in a sense, those differences are going to shape the way we use the language.
Can I change a bit?
Yeah.
It was the last hello world simpler with jQuery.
I'll come to jQuery. I'm doing it chronologically. But yes, it will be. And so one of the questions you want to ask yourself when you get into JavaScript is, what type of JavaScript am I going to write? Am I simply manipulating parts of a web page, small manipulations? Am I doing a whole web application, in which case JavaScript is going to be first and foremost? Am I writing server code, in which case I'm doing Node.js, and it's going to be a lot closer to similar to Python or other code, something I will go less into? Or am I doing something else? And there are ways of doing JavaScript in different environments. So let's attack the history of JavaScript. And I'm going to start with what I'll call traditional good old JavaScript. At its core, JavaScript was meant to manipulate web pages. And in that sense, there are three fundamental pillars to the language. The first one is manipulating the web page. So what we call the DOM, document object model, to create nodes, delete nodes, and things like that. So I've got a bit of sample code here where you have originally one element, and we're going to grab that element, create a new element, we'll add inside of it, add a class to that element, add some text in it, insert it, and create an element, and then insert that element and text into the original element, and you have the output at the bottom. So this was really the core of JavaScript at its origins, is manipulating the DOM to change your HTML layout with code. Add to that event handling, which was really important because you could write the previous code directly. You didn't need JavaScript. But if you start doing that, responding to events from the user, namely, like clicking, keyboard shortcuts, and things like that, you started having really interactive web pages, which is at the core. So here's typical code for having a button where every time you click, you add an element in a list, empty elements, because trivial code. But basically, same thing. You grab your button, you grab your list by ID, and then on the button you add what we call an event listener, which will call a callback function every time we click on the button function, which simply appends a new tag. And those two together already allow us to do to have dynamic web pages. But there's a third fundamental pillar which is going to shape the future of JavaScript, which is retrieving data from the network. And the first function that did that was XML HTTP request at the time. And so at that period, XML was a very light language for describing data.
Nice.
At the time, that's no longer quite as true. But one of the important things is we could actually have the web page request data from the server. So if we think about creating a list, we could actually grab a list from the server, iterate on that list, and add tags or nodes to our web page based on that list. And that means our web pages are now no longer simply dynamic, but also dynamic and exchanging with the server. So this was JavaScript for a while, but especially with this last part, we started realizing we could do web pages which were just about presenting data, but actual full-blown applications. And this is probably one of the first big evolutions which changed the way we saw the web and JavaScript. Is web applications were no longer about writing HTML and then modifying that HTML. We went away from that and went to writing JavaScript and then using the HTML as the entry point for that JavaScript. The JavaScript is now at the core of our web page, and the HTML is simply the graphic user interface in a sense. So with this, we developed a number of libraries that changed the way we interact with the DOMs of the HTML. So jQuery, which was mentioned a little earlier, was one of the most famous, which took all of those functions we had, those primitives, if we'll call them, and arranged them in a way where it was more convenient to manipulate the HTML from the JavaScript and more natural. So this would be the same code grabbing some data from the server and then adding elements to a list based on the data we received. Doesn't look easier, but it is a lot easier, believe me. As that was coming into place, another important thing is, XML was progressively replaced with JSON, which is obviously more convenient to use in JavaScript because it's based on JavaScript. So this made things a lot easier to manipulate. But what really changed is, since we can change the web page now from the client, from the browser, more and more pages were actually built using JavaScript from the ground up. And to the extreme, you would have HTML pages which would look like this, where you would just have one tag in the middle, which would contain your app, one JavaScript file or more, and this is what you would load, and then the JavaScript would populate your page, but you wouldn't be writing any HTML anymore. And so this shift played an important role, because now when you're creating your web application, you're not writing HTML first. That code is always the same, basically. And today you don't even have to write it. You just write your JavaScript. So this client, what we call client-side rendering, was opposed to what we were traditionally doing with server-side rendering, namely using PHP, which is very common at the time. There are other options. One of the main advantages was it would reduce the number of page reloads. You would actually get information from the server without having to reload the page, and it would be a lot more dynamic and reactive. The extreme of that would be what we call single page applications, where even if you had different tabs, different menus and stuff, you'd always stay in the same HTML page, and everything would be re-rendered through JavaScript. And this is still used quite a lot today. It has quite a lot of advantages, mainly in terms of reactivity. The main drawback today that people are pointing out is search engine optimization, because search engines see this and have no clue what your website is about. I think they're getting smart about it. Don't quote me on that. So web applications changed the way we approach JavaScript, and became, as we were doing web applications and more software was actually being developed for the internet, for the web, through web applications, JavaScript saw a big overhaul. So there were a number of game changers, say 15 years ago. The first of which was Google Chrome. Basically, they came with a new JavaScript interpreter, which proved that you could actually have efficient JavaScript. A lot of people still have the preconception that JavaScript is a slow language with low performance, and this was true until V8, so the interpreter for Google Chrome. And since 2008, we've actually been doing very complex, very efficient interpreters. I'd argue today that there's been more engineering in V8 than in GCC, in terms of level of engineering to get it to be very efficient. That's a bold claim. I can't prove it, but feels like it. Another important thing that came is that we were, up till then, scripts were rather small. We were just manipulating parts of web pages. But there came a time where we needed to build big software. And so we had module loaders, basically the possibility of importing one file from the other, which started coming into place. So I just presented two. The problem is these arrived not through the language, but through libraries. And so we had like 5 different module loaders with different techniques for loading modules. There are 2 that are really important today. The first one is common.js, which is used by Node.js, so server-side JavaScript, which uses the require keyword to import and the exports keyword to export. But that is being slowly replaced by ECMAScript, which is now the standard for the JavaScript language, which had its own import system with the import from keywords and the export keyword. And even Node.js today knows how to use this module system. So if you're going to write modules in JavaScript, use ECMAScript import statements, because that's what everybody's tending towards. Don't use everything else, basically. Of course, another very important thing that happened at that period was the creation of Node.js, which is based on V8, which was used to run JavaScript in the terminal with what you would expect from other programming languages, such as access to a file system, which is what I'm presenting here, reading a file from the file system. One of the great strengths of Node.js was that if you had server-client interactions, you could reuse code between your server and your client, because both were in JavaScript. Namely, if you had data structures that followed a certain format and with functions to manipulate those data on both sides, you could reuse that code, which is something you couldn't do before. And you also get sort of the pros and cons of JavaScript, namely, as I previously mentioned, very good asynchronous support if you had asynchronous functions, which is the case often with the server. And finally, I teased this a little bit, but ECMAScript, which is the standard for the JavaScript language, was 10 years back due to rivalries, namely with Internet Explorer, where nobody could agree on the language. And at that period, they finally managed to say, okay, we can try and build this language correctly together. So there was a first version in 2009, which really consolidated the language. And starting in 2015, every year we've had increments which are properly documented and actually drive the language forward. So now it's no longer a small scripting language. It has become a full-blown programming language with a lot of functionalities, which again wasn't the case 15 years back, where it had really the minimum. And all this has brought us to modern JavaScript. So here's a full example, shall we say, with a server, our HTML, which is basically the same I showed you previously. It's empty, save for loading the client, and our client code. So here we're loading a list from the server and injecting the data into our HTML page. So server-wise, I'm using a library called Express. So here you'll notice I'm using exactly what I told you not to use, which is CommonJS, to require Express as the framework. And we're just defining a server with 3 endpoints: one to load the index.html, one to load the client, and one to load the list. So I just put a list of browsers. There's nothing really complex here. What's interesting to see is the async keyword, which is built into the language, which basically says all of these will be called asynchronously. So this is a non-blocking server, give or take. The syntax also has quite evolved compared to previous slides. I was trying to keep the syntax moving with the language. Among the novelties, you'll see that I'm using the const keyword, whereas I was using var previously. ECMAScript brought in 2 important keywords, which were let and const for defining variables. Previously, we had var, which was very lax. You could redefine a variable. You didn't really know how it was scoped. It was scoped awkwardly. A variable defined inside a function could actually be accessed outside of it. Let and const basically got smart. So if you want to define variables, use const. Unless you need to reassign that variable, then use let. Use const. That was one of the big things that actually made detecting errors a lot easier. Another thing you'll see here is arrow functions, which is kind of like lambda functions in Python. You can put a little more inside of them. You can have multiple lines of code inside inside an arrow function. But other than that, they're kind of like lambda functions if you want to think that way. And that's about it for the novelties I've got on this. Sorry, await. So same thing, async await. This isn't a fetch function. So this replaced XML HTTP request with a much simpler API for getting data from the browser, from the server, sorry. And now getting really data from the server, so I haven't gone through the client code, but it's basically await fetch, and you've got your data. And then you can extract the JSON. It's an asynchronous function, so you have to wait it. One of the big differences with async IO in Python is that once I call the function, it's running. I don't have to await it straight away. I can await it later. Because await will block the execution at that stage until we merge. I don't think there's anything really more complex to say about this code, so I'll move on. So now we've got our modern JavaScript. Oh, forgot to mention, how are they called? String interpolation, just like when you do it in Python with fstring, which arrived about that time with JavaScript. So all these sort of things we expect from modern languages arrived around a bit before 2010. And when we decide to ditch JavaScript. So what happens? We're using a lot more, we're building our big applications, JavaScript. But if you come back a few slides, I think I passed through, oh yeah, I went through two things too fast. A lot of the time when we were writing our JavaScript to create HTML, we'd actually be writing HTML strings inside our JavaScript, which we still do a lot. But there came a point where people realized you need to mix the two. We need to have our code which integrates both HTML and JavaScript. Yeah, I skipped that, but that's not all to say. And so we started creating new languages which integrate both. So the first and foremost culprit would be React, which created a language called JSX, extended JavaScript. So React is the framework that's used by Facebook, created by Facebook and used by Facebook for Facebook. But there are other culprits such as Vue.js, which has .vue single file applications, and Svelte. And basically, what does this look like? So I'll start with Svelte, which is really easy. You'll have your script, your JavaScript, and then you'll have your HTML next to it in the same file. And what you'll have is references to your JavaScript inside your HTML. So this allows us to really merge the two together. This is a lot easier to do, to insert the word world inside a string than if we had to create a tag there, grab that tag, inject it through the JavaScript. Here, it's a lot more natural to actually merge the two together. The other approach to this is to do it the other way around. Here, I'm writing the JavaScript inside the HTML. What React does is the opposite. It's actually writing HTML inside JavaScript. Where if you have a function that wants to insert JavaScript, insert HTML, sorry, inside a web page, you can actually write non-string HTML inside your code, and it'll work. So obviously, with all these new languages, the first question that pops up is, okay, but are they supported by browsers? No, only JavaScript is supported by browsers. And so what happens is we've got a whole tool chain which starts appearing of transpilation. So transpiling is like compiling, but instead of generating bytecode, you're generating more code. So in this case, you're going to be transforming your Svelte or JSX into JavaScript. And this has become the norm. More and more, we write things with JavaScript in them, but not JavaScript files. And most of the JavaScript you'll find on the internet today was not written as such, but was actually written in another language or in another file format, and then transpiled to JavaScript. And this is an important trend. If you're building a web application today, this is what most people will be doing. This is what most websites do today. While I'm talking about transpiling, two other languages that are really, well, that you should know about. TypeScript, because JavaScript has no type indications into the language. So if you need type checking, you can do your code in TypeScript, which is an extension of JavaScript. And then when you transpile that to JavaScript, the transpiler will tell you if there's mismatched types and things like that. And the other, less known, is CoffeeScript, what I'm mentioning here, because CoffeeScript basically has Python syntax for JavaScript. So you can write your JavaScript with indentation-based blocks, with comprehensions for lists and things like that. So if you really like Python but need to do JavaScript, you may want to have a look at CoffeeScript.
What about TypeScript or something like that?
I do not know about that, but that's a very good question. There are a lot of transpilers, so I imagine there would be other things that are transpiled to JavaScript. Those are the two I know about. Those are the 20 I know about, but I'll get to the numbers after that. So the one I've used most in all of these is Vue.js, which I use a lot for basically every web interface I use for anything we do, any demo we have. The web interface will be using Vue.js, which allows you to do a full-blown application rather rapidly once you're used to it. The problem is there's a lot of transpiling going on. So I'm going to show the minimal pattern of what happens when you do your Vue.js application and you want to get your web page at the end. You write your Vue.js code. So .view files is basically a file that contains some HTML with embedded JavaScript, some JavaScript, and some CSS, so that you define components that are all built into the same file. And then you'll have a view loader, which is actually going to take that file and separate it in CSS, JavaScript, and I wrote .html. It's not quite HTML. It's HTML render functions, because when I showed, I'll move back here. Here in the self example, if I want to compile this into HTML, I have a problem because I don't know what to do with this name thing in the middle. So what happens is when we transpile that, we're actually going to transform it into a JavaScript function, which is going to render that given a certain context in which name is defined. So the HTML here is actually hidden in JavaScript and will be loaded into JavaScript with what we call an HTML loader. More surprisingly, the CSS is also going to be loaded in JavaScript. Rather than produce your own CSS, we're actually going to have in the JavaScript that populates our web page something which is going to inject CSS as well. So we have our whole web application is just going to be JavaScript at that point, and we're going to bundle it into one JavaScript file. And then we just have our minimalist index.html I showed earlier, which is going to load that file, which is going to deploy a whole web application inside the page. This is the modern way of building web applications. So it's kind of surprising if you're expecting to go into JavaScript and write raw JavaScript code, because you're going to go through this whole process, and if you're not expecting it, it can come as a surprise. More surprising is that that's the minimal example. I'm actually going to walk you through a more complete example just to scare you off. So we start with our template, template codes, where we have a mix of JavaScript, HTML, CSS, and stuff like that. And we're going to load it and separate it with, on the one side, CSS, on the one side, JavaScript, and then the HTML rendering functions. Now, in practice, there are a lot of preprocessors for all these languages, and use them. A lot of time we stick to basic CSS, for example. Basic CSS lacks a lot of support for a lot of functionalities that we would like to have, and often we find ourselves rewriting the same code 20 times. So we have a bunch of preprocessors for CSS, which define variables, which allow you to create a hierarchy between your rules. We also have, so Markdown, I think most people know, where you can actually write your HTML in Markdown rather than HTML, which can make it more convenient. Pug is an alternative to that. And same thing for JavaScript. You can write JavaScript, you can write TypeScript, or extended JavaScript, or a mix of those, CSS, or your CoffeeScript. And what's interesting is that Vue and Svelte allow you to mix that. So when I do Vue.js, I actually use TypeScript inside my Vue.js, which means I don't have any raw JavaScript anywhere anymore. I use less for the CSS. I haven't used Pug for the HTML itself, but I probably could. And then, of course, you need to get from there all the way to your final bundle. So your code is also going to use assets. So when you're bundling all this together, you have to know what your assets are. So assets are images and fonts, basically, as well as possibly including other modules. So one of the things that's kind of awkward with NPM, which I didn't introduce. So NPM is the Node Package Manager. It's the equivalent of pip, but for Node.js. And you have all your Node libraries in there. But not only, you also have front-end JavaScript in NPM. And as you're writing your JavaScript for the front end, you can import code that is stored in NPM. And it will be loaded when you bundle your final code. So NPM stores both as a front and back end repository of code, which is often surprising for people. So if your application depends on code that's stored in NPM, that will also be loaded. And so at this point, we have all the assets we need, all the code and files we need that are retrieved, even if we only wrote one file or just few files, plus the assets, of course, that you need to provide. And then we'll have our different preprocessors. So JavaScript preprocessors, which will make sure that almost JavaScript code gets run into JavaScript. HTML template preprocessors, which creates HTML templates, the JavaScript code for our HTML code. And then the CSS preprocessors, polyfills. Okay. Web browsers don't all support the same functionalities, both in JavaScript and CSS. There are a bunch of CSS rules which are spelled differently depending on your browser or things like that. And that's really a pain for web developers. So what we do is we actually don't worry about it. We write the default rule, and then we run it through a new transpiler, which adds all the alternatives to that rule for every possible browser, so we don't have to worry about it. And this is how you get code that runs in all different browsers, despite them waging war on one another. And once you've got that transpiled polyfilled CSS, you'll load it in JavaScript because we only use JavaScript. Now, as I said, browsers don't all use the same JavaScript as well. Some functionalities aren't quite implemented the same way, and more importantly, older browsers don't implement those functionalities. So we're going to polyfill this code as well, making sure that older browsers can run that code. So if your code uses a novel functionality that was added in ECMAScript 2022, but you want it to run on 10-year-old browsers, we have polyfills, transpilers that will convert that code appropriately. And then you bundle it. And then you minify it. Minification, this is something well, I haven't talked too much about bundling and minification. This is something that really only matters because we're doing web. If you're running Python and your module is 20 files, nobody really cares. It's just as quick as if you put it all in a file. When you're writing for the web, you want one HTTP request rather than 20, even if you're using HTTP2, which uses only one TCP connection. So we tend to bundle and minify our code a lot so that the requests are as fast as possible. So this is common practice. Just good things to have in mind. If you're coming into this not knowing what to expect, it's a lot, and you don't know how to walk into it. Final steps you'll see. So for images, often you'll have automatic image resizing based on the size you're including in your web page. So that same thing, it loads rapidly. And you can have font polyfills because not every browser supports every font format. Again, we're missing one last thing. The index.html. We never wrote an index.html to load all this, and we never do, because in practice, things like Webpack provide one out of the box, which you don't have to write because it's always the same one. So this is the complete build process for a modern web app. And you can add more steps in there if you like. I wanted to go through that just to kind of scare you, but so that you also know what you're getting into if you want to build a web app. Not every use of JavaScript will require going through all that, but it's one of the options. Yes?
I just have a question. When you are building a web app for some goals, where do you spend most of the time? More of the time?
In that file. I only write that
I
file.
was supposing that.
I only write the .view file.
You just write that and everything.
Sorry, I only write the .view files. Those files, I'll have a bunch of them by components, and you define components that can include one another. I haven't gone into their syntax. It also brings something that HTML doesn't have by default, which is reusable. Now they do. Reusable components where you can define your own tags that have their own behavior. And really, yeah, you can define tags, which will have a whole module inside of them with a bunch of tags as well, and really create a modular web page with these languages, which is a lot easier. The problem with HTML and CSS at the base is they are supposed to be directly interpreted by browsers. Browsers, basically, when these things came out, said, I want to read that code and not have to think about it. So you don't have any loops in HTML or in CSS. You don't have any embedding in CSS where you would be able to say, for every A tag and every this tag inside of the A tag, you can't have that hierarchy. Well, you can have it, but you have to do it line by line. So a lot of things were really, the languages are really raw because browsers want to interpret them fast. And all of these provide all these functionality, all these languages provide these functionalities we don't. Sorry, the room is doing something weird, so don't worry on the bridge. All of these languages provide these functionalities we don't have in basic HTML and CSS. So even those things which will look like HTML at first have a different hierarchy and a different structure. But I didn't want to get too much.
To understand better, so you say you spend most of your time, not all on you.
Yeah.
For the styles, don't you work? Do you need to also to work a bit about on CSS or
the view files? So I didn't show view files, but view files
include some CSS.
Yeah. If you think back to the svelte file I showed, you had script and then your HTML. You could also have a style tag.
Okay.
And basically, this has gone sort of the opposite way of a trend 20 years back, where people were saying
Okay.
all HTML on one side, all CSS on one side, all JavaScript on one side, and we separate them.
Yeah.
When you're building components, you actually tend to define all those things in tandem. And so these file formats would merge all three together, are really about building component by component.
And then I have another question about images.
Yeah.
SVG, for example, so when you want to use some images, so you need to get them somewhere.
Yeah.
So what do you do?
What happens here is that your languages will know that your images are in a folder.
Yeah.
And your build process will move it to another
For this
folder.
part is okay. So usually, for example, if you want to draw some images in SVG, do you use some specific tools or?
I actually write SVG inline, or I use Inkscape to build them by hand.
Okay.
Yeah, if you want to do it by hand, but
So you
have
have
an SVG.
some work to do on that when you.
Yeah, I have to build the SVG.
It
SVG is a whole topic in and of itself. I actually like to have inline SVG because you can style it directly through CSS and manipulate it through your JavaScript. So if you have interactive graphics, your inline SVG will allow you to manipulate through the JavaScript, which is really powerful. I haven't mentioned D3 yet. I'll say it afterward, but these are the tools we use. Okay. I think that's about it for this slide. So I'm arriving at the end slowly. I've said a lot of stuff and sort of scared a lot of people off, but what's the takeaway? Is there are a lot of ways of doing JavaScript. And when you head into, I need a graphic interface for this or that thing I want to show, first question you should ask yourself is, how much JavaScript do I need, and what sort of JavaScript do I need? So obviously, is it a single web page with like a few components I need to manipulate, but most of it is just static? If that's the case, you're probably just going to write some JavaScript on the side and not use the whole framework. If you need a full web application, then you probably need a framework that'll help you a lot build it. Of course, if you're doing a server, then you're using Node.js, which is a bit different and more classical, which is why I haven't gone into it as much. It feels like any other code. Regarding web applications, you have two choices. So here again, this presentation was about JavaScript, so I spent a lot of time on client-side rendering, but you could also do it server-side rendering. And just to give you the tool, so client-side, if you're doing a full web app, I mentioned React, Vue, Svelte. There's also Angular, which is quite popular. If you only need to manipulate portions of a page and want to write the rest as static HTML, you can. In which case, as we mentioned, jQuery is really great at manipulating elements to help you manipulate part of your web page. D3.js is really good at creating graphics that will be based on data you have and updating that graphic as data is updated. So if you want like a chart or a more complex graphic representation of your data just in one portion of your page, then D3 is probably the library you want to look at. If you're doing server-side rendering, depending on what your server is running, there are a lot of template languages for their server side. So just like PHP is a template language, if you're using Python, Flask has support for Jinja 2 template language. I don't know if people using Flask have used that already in the past. It allows you to write your HTML with room for populating it with variables you've defined in your Python as you serve a page. Pug would be the equivalent for Node.js. And then other questions you just ask yourself. You need type checking. Can you only abide by Python style syntax? So I mentioned CoffeeScript if you want indentation for your blocks, because that's what you're used to, which I can completely understand. Pug uses the same format if you're doing your HTML, and Stylus uses the same format for your CSS. So if you only want indentation-based blocks, you can actually do everything with that using those three languages. Because I know some people like that. And if you need a build process, I talked a bit about Webpack, which is basically the JavaScript equivalent of Make nowadays. There are alternatives. Gulp and Grunt are the two most famous. It's a lot of stuff. I don't expect you to remember it, but it's nice to know what you're getting into, especially when you start reading Stack Exchange and trying to get information about how to do something, and you come across all those words. It's like when you're doing Python, you need to know what pip is, otherwise you're kind of lost. And it's good to know what NumPy and SciPy are. Otherwise, a lot of explanations don't make sense. And pretty much, I think my final slide is all those things I didn't mention. Just again, to give you vocabulary, if you will. NPM packages that are good to know about. Express, which I showed very quickly, is like the equivalent of Flask in Python. You need a simple REST API or HTTP server. Express is probably the library you want. Fastify is a more recent alternative. WebSockets. This is a really recurring question for web pages, is how do you maintain a connection between the server and the client? For a long time, the default attitude was, I'm going to ask my server every second, is there an update to the data? Is there an update to the data? So we got smart about that, introduced other techniques such as long polling, where I ask, but the server only answers after 5 seconds if it doesn't have any data before then. But then WebSockets came in, and today most web applications actually use Socket.io, which is a library which uses WebSockets, but makes it a lot more convenient to use because raw WebSockets are a bit of a pain. So if you need communication, bidirectional communication with your server, that's the library you want to look at. Testing, linting, if you need those. Debugging, debugging system for JavaScript built into Node.js. Sorry, and hot reloading. If you're doing Node.js and you want to restart your server every time a file changes, there's a package that does that, which is really convenient when you're developing. And then there's iPut database. There's a bunch of classical stuff. The most common database used for Node.js is MongoDB, and it has a great library to work with that. That's mostly backend. Concerning the front end, so we mentioned jQuery as a great utility to access the DOM. Two other very common utilities are utility libraries, sorry, are _JS and Lodash. And then for displaying data, because that's something we love to do. So I mentioned D3. Chart is a little simpler to use for just displaying charts, but less possibilities as well. If you want to do LaTeX in your web page, MathJax, sorry. And then if you need 3D or maps, you have 3GS and Leaflet, which are just same thing. Common. If you need those, it's good to have a name somewhere written down. And finally, last piece of advice: use the console a lot. So in Node.js, just like Python, you can just run Node in a terminal. It'll open a read about print loop, which allows you to check if you don't remember whether null equals undefined returns true or false. Check it like that really fast. And in the browser, use the web console and the development tools. They're very powerful to know what's going on in your web application. It's something people forget. They try to run the code. The web page doesn't do what they want. You want to inspect your DOM, your console, see if there are any errors. So when you're building a web app, your web console should be open all the time. It's generally F12 to open it in the browser. And yeah, don't forget that. I think that pretty much sums up my presentation.
Thank you.